right, so I'll go ahead and kick it off. A brief introduction again. Welcome everyone who has joined. This is an ATG town hall series. We're going to talk about curtain wall casework. This is a very interesting approach to handle one of the tricky families inside of Revit, that being casework. My name is Emily Clark. I am the Director of Architectural Services here at ATG, and it is my pleasure to both have Matt Lin and Nicholas Chan for this presentation today. I'm excited to see what they have to showcase, so I'll let them introduce themselves. Before we jump into that, I do want to do some housekeeping items. Everyone is already muted. If you have any questions for either one of the panelists, go ahead and type those into the question and answer box. I will be moderating that, answering any that I may be able to, holding those until the presentation is at a pause so they can be addressed at that time. You can use the chat panel if you want to chat amongst yourselves, talking about how cool this tool is or any sort of general feedback like that. But specific questions and answers will be in the Q&A panel. So with that being said, I will turn it over to Matt to introduce himself and then Nicholas to get it started. Thank you, guys.
Thanks, Emily. Good morning. My name is Matt Lin. I am a technical specialist here with ATG USA. I am a licensed architect and have spent the majority of my professional career in the traditional form or the traditional sense of architect. These past 3 years, I've made a transition over to this BIM consultant role, and it's been great. It's given me the opportunity to work with folks like Eigelberger and Nick. Nick, I'll pass it off to you.
Hi, my name is Nick. I am the studio director and a senior project architect at Eigelberger Architecture and Design. We're based in Colorado and LA. We have offices in LA and Basalt, which is right outside of Aspen. Before we get started into all of this, I'd like to give a little bit of an intro to our office to give a little bit of a background to how we discovered the need for this tool to make our workflow a little bit easier and to be able to communicate the various designs that we have. I'll start off by rolling through some images of our built work, some work that's in progress, some renderings. So we do mostly high-end residential in different regions, in the mountains of Colorado and Utah, in California and LA, and some work in Florida as well. The styles that we work on vary from some more contemporary modern to more classic design, mountain homes, and again, modern within different climates and different areas. We're passionate about doing great design that's tailored to the clients and the project's specific needs. And as a creative firm, we often use tried and true design elements, but often we encounter novel design problems that require flexibility and adaptability. And I'm just showing exterior photos right now just to show the overall design aesthetic and some of the various forms it takes. Of course, this meeting is going to be primarily focused on the casework, cabinetry, and built-in methods that we've worked with ATG on to make this workflow a little bit smoother and more adaptable. So with custom cabinetry, we have a lot of kitchens and other spaces that are that differ in design and aesthetic. We want to be able to communicate this clearly and adapt to the changing design too. And it's, in terms of custom design, we often go through many iterations of designs with our clients. And so we needed something that would allow us to show different designs quickly in both 2D drawings as well as 3D renderings. So these are some images of some of the various detailing that we do, and we wanted to find a way that would allow us to get to this level. Maybe not necessarily model everything down to what is shown here in these images, but something that would allow us a flexible and a good baseline to build upon. If I go back to this one image here, so there's various custom pulls, integrated pulls, detailing of borders around some of these cabinetry fronts and drawer fronts. And while kitchens and bathrooms are the majority of where we find built-ins and such, there's so many other spaces in the custom residences that we work on that demand this attention to detail and adaptability in design. Mudrooms, of course, kitchens, game rooms, living rooms, and we found that this tool can also work for bedroom for bookcases in spaces like this and in bedrooms. And sometimes our studies take on our designs. We push them into photorealistic renderings like this one above to help visualize the space, or even perhaps to sell it before it's built. This is a really useful tool for us, and we wanted to streamline this to make this something where if we didn't go to a third party to get renderings, or even if we did this in-house, to get that level of detail in a rendering from Revit as smoothly as possible is one of our primary goals. In-house, what we use often is Twinmotion. And if you can see here, this is a good example of what we were struggling with a little bit before. On the right-hand side, you can see that these panels for the cabinetry, they show the leaves and the panel breakouts clearly, which gives a sense of what that space is. On the left-hand side, all you see are the poles, which have been modeled, but the face of that is all just one surface. And even if we describe that with model lines or symbolic lines, that level of detail in the rendering is not going to show through. So at a very conceptual level or schematic level, this was acceptable because we often wouldn't get to that level of the different dimensions of cabinets and drawers. But as we move forward into SD and further into SD and into DD, the need for understanding the space and getting that feel for that space with the level of detail in the built-ins became more necessary. So at the end of the day, of course, we want to have two-dimensional drawings, interior elevations, details, dimension drawings to provide to the GC and others to get these projects and these designs built. So in addition to having the ability to model something quickly and to get that level of detail relatively quickly, we didn't want to give up that workflow. We didn't want to have to redraw, remodel, and retool everything once we moved into CDs. We wanted to try to streamline this as best as possible, while even at this more advanced level, having the flexibility to adjust certain things. It's not unusual for us in some cases to have an owner or client request some changes with these models. And if we custom modeled every single one of these and had to change something in the future, it does require a lot of work, and we wanted to try to remain as adaptable and flexible as possible. So the tool that we worked with ATG and Matt really helps us get there with this flexibility. We want the ability to, as you can see in here, for example, with the elevation of the drawers, we want to be able to show each of those with just one line in a 2D drawing. We don't want to have to show the two lines that generate the actual modeling that's needed for Twinmotion or other rendering programs. So this was all built into the tool to allow this to happen. One of the notes that we had too is the in section, as you can see on the right-hand side, we decided that at this current time, level of detailing and the level of information in those sections is often so customized. It was a little difficult to get this system to adapt to show all the guts of the built-ins, if you will. And that's something that, in our opinion, is better left to detail or detail lines that can be picked up later and not necessarily be part of the actual modeled element, especially since this is something that you would never see in a rendering. So the main focus was to allow elevations to be built, to be modified quickly, and for it to show up in renderings like this one. At this point, I think that's the quick. Well, before I get to that point, the origin of this idea, I don't think I can take, or we can take full credit for it. Like most good ideas, this was generated as an employee that recently left the Arizona firm a few months ago. He got this idea from another architect whom we both happened to work with in the past, and I'm sure that guy got that idea from somewhere on the internet. So this is a building of multiple people's experience and ideas, and partnering and collaborating with ATG has been a pleasure, and I look forward to continuing that and continuing to evolve this as well. This is a very useful tool. Like all tools, it's a work in progress that can use continual improvement. Matt, if you want to take from here, if there's any questions.
Looks like there aren't any questions as of now. That was a great introduction. I really enjoyed kind of seeing, the progression and, in that certain phase, what it did look like and not being able to fully represent exactly what you were trying to communicate and having that ability and flexibility. So I'll let Matt show the ins and outs.
Great, thank you. Nick, before I get started, I would like to say that is really beautiful architecture. So kudos to you and the entire Eigelberger team. Really beautiful stuff. And I was blown away that some of those are renderings. I just assumed they were all photos. So kudos again to you guys.
And actually did have a follow-up question before you get started, Matt, when we're talking about the renderings. So do you guys primarily use Twinmotion only or any other software? Because I jotted that down and then you kind of answered it, but just making sure because those look really nice.
Yeah, so these when we do quick renderings in house like this, as some of you may know, doing Twinmotion almost takes no time to pump out images. They're not as high quality as these ones, of course. So these ones we use 3D Studio Max, and we also partner with some rendering firms who use slightly different software. But with all of those third parties, they if we give them a model and the design, they often have to go into the model itself and start to like that reveal between the countertop and the shelves below. If that wasn't modeled in our model, that's something that they would have to do in their model, and which is okay for the third party to do, although it may increase the cost of the rendering. But what we found is we wanted the ability to do this quickly in house, at maybe a slightly lower quality level, but this gives a very good idea of what that space would feel like. And Twinmotion is one of the primary rendering programs we use with Revit to visualize spaces.
All right, thank you.
All right, so let's get into Revit. So I'll take over from here. Okay, so first of all, let's kind of just have a proof of concept. So as Nick mentioned, the goal was to take a casework and turn it into, take Curtainwall and turn it into casework. So why go this route? Curtainwall is grids, mullions, and panels, and casework is countertop, base cabinets, and toe kicks. So it just kind of makes sense. If you think about it, it's counterintuitive. In fact, when Nick came to me, I was like, that's really peculiar, but let's explore it. But it actually worked very well. One can represent the other. Okay, so here we have a curtain wall, just a standard one. And this is the out-of-the-box standard storefront. So within any curtain wall, you have the type properties where you can specify what the curtain panel is. In this case, it is glazed. It could be anything. It could be any standard wall. And then it also gives you an opportunity to specify both the vertical and the horizontal mullions. And you can specify what goes in both sides of the border as well as the interior type as well. Okay. And if I come in and select it, you can see that is just a standard rectangular mullion. There's a curtain grid. The panel itself, in this case, it is the glazed version. And then the bottom mullion, again, just a standard rectangular mullion. Okay. So if we zoom into the casework, we can see kind of all of those same things, right? The countertop could be a mullion. The toe kit could be a mullion. So again, this is just a curtain wall. This one is called a 24-inch 1 1/4 shaker. So the curtain to panel is defined as a shaker door as default. You know, it could be a flush door, shaker door, and it could be any door. You just got to build it. And then the border type 1 is the toe kick, which again is simply a mullion to put in Revit terms. And the countertop is also a mullion to put in Revit terms as well. Okay, so if I come in and grab the countertop, we can see that is a mullion. Again, the door, which in this case is the shaker door, it could be any door that you build. And then the toe kick, again, simply a Revit mullion. So if we come look in the project browser, so here is the type properties for the specific one. So all we did was we subbed out those components as opposed to traditional panels and mullions. Okay, so first we'll take a look at the curtain panels, and this is where we build the doors. And okay, so the first one is a flush door. We'll come and look at it. We'll just look at this one real quick. I want to focus more on the shaker door, which is located here. And you can see there's several types within each family. And so within the family, we went ahead and built the door swings as well as the casework, and then created parameters, visual controls and dimensional controls to control where those land for each type. Okay, so we'll turn the preview on. Okay, so first we have the awning. We can see with the swing going down. The default is the one that comes out of the box when you first use it. And by design, this one does not have a swing or a hardware, because when you're in SD mode, you're just kind of laying it down. We want millwork here, we want casework here, and so forth. You're not at that time specifying what all those doors are. So it's kind of like an out of the box starting point. Okay, then we have a drawer, a hopper version. And you can see all these doing is controlling the visualization of both the door swing and the hardware, a left door and a right door. Okay, so I'm going to come back out of the preview visibility, and I'm going to close out of this family. Actually, first, I'm going to show you, it also has a few dimensional parameters controlling the rail width as well as the style width, and where the hardware lands in according to the edges of that panel as well. All right, next we have the door panel. So if I come down here, get the countertop. Okay, so for the countertop, all it is, it's a rectangular mullion, and then we specified the profile. Okay, and the profile, again, could be anything you want. So a rectangular mullion obviously is a rectangle, but it wouldn't have to be. It could be any profile you want. So all you do is simply build in that profile and apply it to that mullion. So we'll come here. And so we built in a few dimensional constraints to control what we want to see here. So when Nick came, he said, we want to control 3 basic things out of schematic design. We want to control the panel thickness, we want to control the casework depth, and then the lip overhang. So we basically just built in those 3. You could build in as many as you want or as few as needed, but this worked for Nick and the Eigelberger team. Okay, next we have the toe kick. Again, is simply a rectangular mullion. So if we come in here and look at the type properties, it's a mullion representing or referencing the toe kick profile. Okay, so if you look at the type properties, it also has dimensional constraints for the casework depth, toe kick height and depth as well. So in that family, okay, it's got that shape as well as these dimensional parameters as well. Okay, so that's the guts of how the system works. We're basically just taking pieces of Revit Curtainwall, and transitioning those pieces to pieces of casework. Okay, so as Nick described, the Eigelberger team would, out of the box, they want a way to quickly manipulate and adjust these things when you're laying it down in plan. So when you're in schematic design, you're not drawing the doors, you're not getting too detailed. You're saying casework goes here, and I want to be able to put it down super fast, and I want it to be able to manipulate, and I want it to clean up around inside corners and outside corners, and I want it to show appropriately, as Nick mentioned, in both plan and elevation, and three-dimensional renderings and so forth. So that was the next phase we explored with Nick. Okay, so as you know, curtain wall in Revit is simply a wall. So to draw a wall in Revit, it's pretty easy. You just lay it down and plan, right? So that's how simple it is. You just draw it down. We'll go 10 feet over. So as I'm drawing this, you can see the countertop is automatically cleaning itself up. Okay, so I'll draw a basic shape showing both inside and outside corners. If we come and look at it in 3D, the countertop has cleaned itself up. The panels are showing. We have the toe kick recessed about 4 inches by default. And you can see it cleans itself all the way around. All right, what if we don't have 90 degrees corner? What if the angles are sort of all over the board, okay? Chances are you're not gonna do this with casework, but if you ever do, it will also clean up just like a 90-degree corner. Okay, you can see the point of the countertop, the point of the toe kick, the panels coming together at corners. Here's the inside. You can see what that looks like inside the casework itself. Okay, so now I'm going to delete a couple of these. Again, these are simply walls, or curtain walls. So just like you would with a traditional wall, you can use all the same tools. You can trim extend, for example. So just by hitting TR, you can trim extend these to join up and they clean up. Same thing, I'll grab these two and delete them and trim extend those. Okay, maybe this one with this one, and we'll come and delete these 3 items. Okay, so what are some other things we can control with just a standard wall, right? We can control the height of it. So just like you could in a traditional wall, you can do the same thing here. Here's the unconnected height. You can put it in any value you want. Okay, if it's a taller, like up high, 6 feet, you can go even higher. Or maybe it's an accessible countertop type, so you can put in 2 feet, 10 inches, any height you want, and it'll automatically adjust the height of those panels. And it's holding a consistent countertop thickness via that parameter. Okay, you could also come in and say, all right, let's move to a shaker type panel, which will automatically swap all of them out for the panel and any other type properties that happen to be baked into that type, that wall type as well. Okay, so the next part, Nick mentioned they wanted to be able to take this and seamlessly roll into renderings, right? They want to explore different materials, different colors, how that looks in the final image. What does the owner think? So, and this one was actually fairly easy to incorporate because a lot of it was native to Revit already. But for any custom comment, custom content you make, you just have to verify you're adding those material type parameters to your content. So just quickly shifting it over to a realistic view, you can see those are populating automatically. Now, again, the mullions are easy because it comes stock out of the box with a material type parameter. Same thing with the toe kick. Okay, I just indicated some arbitrary finishes here. And then the panel, if that is something custom, which it always will be in this case, then you'll have to go ahead and create some new material type parameters for those as well. Okay, so what happens after that? What if when we're ready to move into DD and CD, how does that transition? Ultimately, we don't want to put all this stuff in SD, go through and delete everything, right? We want it to roll right into DD and SD. So that was the next phase of this, is just verifying that this method could in fact make that transition smoothly. Okay, so I'm going to come and I'm going to delete these items. And I'm going to create a couple new ones. Again, I'm just grabbing this wall, CS for create similar. Adding one here. Adding another one, just copying it over. All right, and I'm going to create a section so we can see what this looks like in elevation. Change the detail level real quick. All right. Now I'm going to hide my crop. Okay, so here's one. Here is the flush version. I can grab this entire wall and switch the whole thing to shaker, and then it's looking to those type properties, which in this case, all it changed was the door type. Okay, so in curtain walls, you can come and add grids, right? And that'll automatically start segmenting up your walls. So that's the transition from SD to DD into CD, is you can use curtain grids anywhere you want, and you can start breaking it down into panelized pieces. Okay, so equally spaced is probably the most common method to start breaking this down. So we'll do that over here. Same thing over here. It should snap to the midpoint. Okay, so now we are breaking this down to 2.5 foot doors each. Okay, so if you recall, this had type properties as a flush panel by default. So when you indicate that in type properties of a curtain wall, it will by default pin your panels and automatically make it that flush door or whatever is indicated in your type properties. Okay, and that's why it's grayed out up here. So you can choose anything you want. The only difference is you just have to unpin it. So I'm going to come in and I'm going to grab all the panels on this curtain wall and unpin them all together. So then I can come in and pick any panel I want, right? So I'll do that with this. I'll come in, I'll pick a right door, pick a left door over here again, and another right. Now thus far, it looks pretty much exactly the same, right? So we'll get to that here in a second. Okay, I'm going to push over to this side, do the same thing, grab this. Actually, I have to unpin them first. So I'm going to select all the panels on the host and unpin them together, and then come back and swap these out for anything I want, right? So that's a left door and a right. Okay, I meant to do a shaker door. I'll come back for that. So a right shaker door and a left door. And then for these, we'll pick a couple of the other options. We'll do the awning and hopper for this one. Okay, so far it looks pretty much the same, right? So another thing we baked into this as we explored this this workflow with Eigelberger is how can we control what we want to see? So we started using detail level as a method to establish what all we can see or not see. Okay, so as we jump to medium and fine, you can see that visibility changing. Go back to medium, shows a little bit less. So if I zoom in here, all right, I'm going to go back to coarse. So at coarse, you see the panels. You can see how it's broken down via the curtain wall grids. When you jump to medium, now you can see the door swing and you can see the hardware as a single line diagram. And then at fine detail level, you start to see the raised panel as well as the thickness of the hardware as well. Okay, so that's all controlled within the family of that panel, which you can do with any custom family. Okay, so for this one, if we want to move the hardware, we can do that. We've built in some constraints to control where that lands on the door. So we'll move this one up, we'll move this one down. Okay, so those are just offsets from the edge of the panel. All right, so far all we've done is vertical grids, but just like with a curtain wall, a grid can go both ways, right? It could be vertical or it could be horizontal. So you can start to break your casework down horizontally as well, which is simply another curtain grid. So we'll come in and add this one here. And since those are already right and left doors, you can see it made additional right and left doors. So if I want this to be, let's say 5, I think I hit the wrong line, come back, hit the correct one, pull this dimension off. So let's say we want a 5-inch drawer. Okay, so I'm going to grab that grid and move it. Okay, now what if we only want it on the left side? Okay, you can come and pull out any out, right? You can make it just on the left side, just on the right, one in the middle, it doesn't really matter. So now I can come in and grab each one of these panels, which are currently left and right doors, and I can turn them into drawers just by selecting the correct panel type. Okay, now I can come and grab both of them, revise the offset for the hardware, put it right in the middle at 2.5 inches. Okay, so what about in 3D? What do we get here? So I'm going to go back to the coarse level with hidden line. Okay, so at this level, you can still see how they are panelized down. If you have drawers, if you have, the grids themselves will show, so you can see how it's broken down into doors and drawers and, however you break that down. And as you come in and adjust, I'm going to switch the scale first so we can see that a little better, a little clearer. And as you adjust the detail level, again, the door swing and the hardware will start to show as a single line diagram at medium, and again at the full dimensional constraints of the hardware at the fine detail level. Okay, back to medium and back to coarse. All right, so if we jump to realistic view, again, that detail level is still baked in. So even with the rendered materials, you can start to see the hardware. You can see the, the pulls if you want to. Okay, so that's kind of the end of the demo portion. Did we have some, looks like we do have a question come in.
Yeah, we have a few questions. The first one is, I actually might do these in a little bit of a different order than they came in, based on what you're currently talking about. So the first one, I guess we'll go with, how long did it take to make all the subcomponents to allow them to be used in the curtain wall system? Maybe just an estimate of how much time went into creating all those subcomponents.
Sure. So things that are simple, like the countertop, and the toe kicks was really pretty fast because, you know, the countertop is essentially a rectangle. The toe kicks are a little bit more interesting, and here I'll show you that. Actually, I'll go into that one. So if we go, okay, the question is time. The question is time. It's
I mean, and I know that's kind of hard to.
Depends on the complexity, right? If you have a rectangle, you can knock it out in 15, 20 minutes. If you have something like a shaker panel, it took longer. It took half a day, something like that. Would you say, Nick, something like that?
Yeah, I think something like that. And it's not in addition to the modeling of the shaker panels, all the parameters that had to be built in to make this thing be modeled correctly in 3D. So it showed up in renderings, but then to have the ability to turn stuff off, to have those isolated detail elements come up in a 2D elevation, to be able to get that level of control. I think it might have taken longer too, like with all the different types. With you have, you know, the shaker panels and solid panels and different types of operation, location of the hardware. I mean, one of the things that we haven't gotten into quite yet is doing an integrated pull that doesn't span the whole length of a panel. Sometimes you have a finger pull that goes the whole length of a panel. Like with what's currently built in here, we can illustrate that in 3D and 2D. Literally modeling that with the actual dimensions of the pull was not a priority. We just wanted to be able to show this in 2D and 3D, and then a detail could capture that. So there's other levels of development that could be baked into this a little bit further. But I would say, I mean, Matt, you're the one who spent the time doing it, so I think you have the best grasp.
Right. Just as Nick alluded to, basically, the more constraints you put in it, the more flexible, the more parabolic it is, the longer it takes. Countertop, again, 15 minutes. These shaker panels, half a day, and anything in between. Okay.
So there's a question: can the grain direction be manipulated for the site and rail?
The grain direction. So, I mean, I guess you could essentially create a new material that swaps that material, and then you apply it. So you could have a material called wood grain standard and then wood grain 90 degrees. And then you'd have to apply those. You have to break it down into pieces. So if you had this door, you know, you could model the style as an extruded element. You could model the rails as extruded elements and then apply those materials separately.
And there might be a detail or an annotation symbol that indicate grain direction that's built into this. So yeah, with styles and rails, they need to go different directions. So that's another level of complexity, but I think it can totally be built into the system. It's just another set of parameters.
Great point. And those could each have their own toggle yes, no parameter when you want to see them or when you don't, and so forth.
Do you ever integrate backsplashes, or are they always modeled separately?
So that's a great question. And when Nick first approached us, we did integrate backsplashes. So here's what we were up against and battling in the beginning. That's not to say it couldn't be overcome over time, but initially what we're up against is this profile. And by the way, we created the backsplash as an L shape for the section, you know, as opposed to a rectangle, it's an L, right? And the back side of the L is the backsplash itself, which worked pretty well. And you could control the height and so forth. The downside is when I select this wall like this, I can see the unconnected height is 3 feet. So 3 feet is the top of that countertop, which is what you'd expect, right? If you have a 1 foot tall backsplash, the countertop would then be at 2 feet. You know what I mean? Because it's looking to the top of that mullion, which in that case would be the top of the backsplash. So like I said, there's probably a way to overcome it. We kind of came to the point, you know, Nick said, you know, our backsplashes are often varied so much, it's probably not even worth incorporating in this version. So for this round, we decided, let's just make it its own thing. Good question though.
What about curb?
To that point,
go ahead.
Oh, Sorry, I
Go
just
ahead,
wanted
Nick.
to tag along there. There's another question here of how we deal with the categorical integrity of using walls for casework, and if there's any conflicts that we see coming about from that. In regards to and this does relate in some ways to a backsplash. I mean, we would either model it in place or do a wall sweep for the backsplash to accommodate that. And in terms of categories for walls, we typically show built-ins at all levels, like in RCPs and plans. We never really have to toggle that on and off with other walls. So we haven't come across that yet, but we've obviously tried to think ahead about this, and we don't believe it's going to be an issue for our use in our office. But the fact that it is a curtain wall, that might allow us to help filter some stuff out, because we don't typically use curtain walls in our other doors and windows. So our offices, we use doors and windows, and then the only instance of curtain walls is really now this use here.
That is a great question. And another thing, you're right. I mean, if you want to be a purist, it's not a category of casework. It is a wall. But to overcome it, a workaround would be to just use filters. Create a wall filter for casework and filter it out of schedules or views or whatever you want to, however you want to use that filter.
Yeah, that actually came up as well. Questions about, and it depends on whether or not you actually schedule out your casework or if you just show them in an elevation. But how do you address scheduling and or tagging, because it is not truly a casework category?
Yeah, so it's kind of the same answer. It would be, as opposed to a casework schedule, when you go to schedule, it's a wall schedule. And when you do that wall schedule, you would come in, say schedules, and you would go to walls. And then when you go through and make it, you'd end up using a filter and applying that filter to, casework equals yes for a yes, no parameter, for example. And then it would isolate down to those. I see a lot coming in here. We'll try and answer fast.
Yeah, I'm just going to start going down the list.
Yeah.
So Paul had a comment. Looks like the location line is the front edge. I assume this was chosen to solve the issue of the curtain walls trying to clean up with the surrounding architecture, other basic walls, that is. So what was determining the location line, and was there thought behind that?
Paul is absolutely correct. Yes, because the initial round, I actually had the location line at the back side. To me, that made sense intuitively, because if I want to follow a wall, I want to be able to follow that wall exactly. And just as Paul's pointed out, the mullions or the countertop and the toe kicks were not cleaning up that well. So as soon as I pushed that to the outside, it was like magic. So we were kind of stuck with that. And then, obviously to address the point of laying it down, you can always in plan, if that's your wall, for example, you can still lay it down by saying wall, and then use this offset right here of whatever the thickness of your casework is, and pretty much lay it down the same way.
Let's see here. What about curved casework?
What about curved casework? Okay.
And when I first read this, I was thinking, how could this be achieved? I mean, could you use just something similar to, the curtain wall one that just lays out a sheet of glass, and you go in and divide up the mullions, or you divide it up with the grids, and it'll segment it. I'm not sure. I know this is something you typically don't do, so I don't know if it was vetted out, and nothing just like throwing a curveball for you to try to do that live.
Why not, right? Let's go for it.
No pun intended there, but we haven't investigated curved casework because it's something that is it's a little atypical. I mean, we do curved casework, but the majority of our of the designs are more linear. Like what Matt's showing on screen now, you could segment it, but I believe the question would be like doing like true curved casework, which we sometimes do, but it's not typical, so we haven't really addressed it. So if it's an approximated curve, like what's on screen right now, it's obviously working. So because they're all flat panels, but I don't think that we maybe can have a curved panel for this. That would be definitely highly custom and not typical.
And that works exactly as I envisioned it playing out to be. So excellent. How do we keep the panel as shown, but use different hardware? So do you have the ability to swap out different hardware on a particular panel?
Yes, you would, and that would be all how you build the content itself. So if I were to come into this and edit family, the hardware in this case is simply nested hardware, right? So if I came in here and edited, I could change that out for whatever I want, or I could nest in other families and control whether I want to see it or not see it via yes, no parameters. So all that is a nested, it's just a nested family right there. So it could be any hardware you want. Good question.
Okay, do you ever get into levels of detail where you would show filler panels, et cetera?
These three questions from the anonymous, but also from Norm, I think these are all related to each other. And
okay.
Matt, if you could demonstrate the offset. So there's a micro offset that shows the separation of the panels for the rendering programs to show that gap. You can modify that to increase to show more. If you want to do something like a half overlay or something that really does expose a filler panel or the cabinetry behind a cabinet door, then I think where, Matt, you were just about to go, you can use rectangular mullions to approximate that. To show, say, maybe there's like a 1-inch gap between these cabinetry doors. You can basically create another grid line and then offset that, and then have a mullion in the back to either have a filled panel. This can be done a couple different ways, I guess. You can use mullions, or you could actually do a filled panel. However, the filled panel might be flush with adjacent panels, but we can adjust the depth of these panels to allow for that to be realistically shown in the rendering.
Yeah, and to take that a step further, if you have like an offset panel and you really want to see the dimension or the depth of it, it would probably be better controlled in the family. In like, if I were to come in this family and edit it, you know, this is just one simple extrusion. You could make it offset in the family, you know, and have like another extrusion out here, and then it would really pop. And then you're getting it automatically every time you put a curtain grid in. Okay, next.
Okay, a couple questions on demonstrating what you would do on an end panel where there isn't a wall.
Okay, great question. To date, I can't think of anything to do right there. We'd have to explore that, but we didn't address it in this round.
That was resolved, I believe. We did it's a vertical mullion that we use. That's the full depth of the cabinet, and it either stops at the bottom of the grid of the toe kick, so you don't have a end panel that goes all the way down if that's not what you want, or it can go all the way down from underside of the countertop. Yes, something like that. I believe that's the question is how do we deal with that end condition?
Yeah,
which occurs all the time. Using mullions, you can toggle the different joint conditions here, the thickness of it, to get generally what we find at these conditions.
Did that sufficiently answer that one? Okay.
I believe so. Yep. What about shelving? How is shelving incorporated into casework?
Okay, so that's Nick kind of alluded to this earlier as well. So we're not in this instance, we're not physically modeling it. We did have an instance where in the kind of the beta version, working with Eigelberger, we came in and say we went in this section here. Okay, so we modeled this piece in the family to have symbolic lines. And so the symbolic lines would show shelves, and we had some parameters, yes, no, for 1, 2, or 3 shelves, and we'd space them equally and all these different things. The downside to that is if you're looking at, let's say this curtain wall continues like this, or this casework, I should say. We've got a bunch of things going on here. Delete this one. Okay, so if this came around, oh, wrong side. And then if we look at that, we would end up seeing that here in elevation, because as you know, symbolic lines you can see whenever you're in a perpendicular view. So it's kind of a bust there. So we did start to explore it. Otherwise it could be, you could start to use model lines, but again, that's only going to be in that plane. So thus far, we haven't really addressed the true modeling of shelving, but we did start to explore it in detailed view only.
Yeah, the idea there for the guts inside of the cabinetry, shelving drawers, otherwise, those are typically done with symbolic lines, and if we use frequent sections that appear in these cabinets, we're looking at developing a detail component where you can adjust that for symbolic lines. But the question may be related to open shelves, like bookcases. If that's the question, we would use the horizontal and vertical mullions to literally model an open bookshelf, which we find pretty useful because it literally models it and you don't have, it's a really quick way to model something, especially if you set a depth of a bookshelf at like 14 inches or whatever, and then you have other shelves that are deeper or whatever it might be, using the curtain wall system and curtain wall grids to align and manipulate this has worked fairly well for us.
That's a great point, Nick. It's basically a mullion extruded the depth of whatever your casework is for open shelving.
Correct. So we can have a combination, like in some of the images that I was showing of some of our built work, we often have open shelving in kitchens next to appliances, next to drawers, next to closed cabinetry. And all of that we can fit in with this curtain wall system.
Have you ever considered using adaptive components into this tool? I don't know, maybe that might be the next phase of development of this, but I don't. Has it been considered up to this point?
We have not explored that method yet, no. I don't know if you guys have yet internally, Nick.
We have not yet. We're just having a lot of fun trying to use this tool right now.
Yeah, absolutely. And I believe, I'm not sure if this was addressed in the questions. I think we've pretty much hit everything else, but have you encountered any issues or any instances where countertop mullions don't show? When a mullion profile is taller than the width of the panel, we've had issues with mullions disappearing.
I did not come across that, but what you're looking at is what I was playing with. So I'll kind of ask Nick, in the real world environment, have you come across that at all?
Not yet. If I understand the question correctly, if the mullion extends beyond the top of the curtain wall, that becomes an issue. Is that? I'm trying to find that question here.
Yeah, that was the question.
Okay. Well, if I understand the question correctly, the curtain wall itself needs to, I believe, extend to the full extent of where you want the mullions to extend to. So if say there's a vertical mullion or panel that extends up to the ceiling here, you would need to change the height of the curtain wall to go to the maximum height of all the elements inside that curtain wall. Is that
correct? Yeah, that it's kind of similar concept as what we're working with the backsplash too. Yeah. And another thing worth noting, something we did explore, Nick and I, is in the vertical grids. I don't know if you noticed, but whenever I use grids, well, let me back out. Within edit type or the type properties, these are all set to none. And we did explore, like, what if it was like a 1-inch mullion? And it kind of messed up. And so we found the vertical joints were better addressed in the panel and simply leave the verticals to the grids, because it did have some hairy connections when it meets both the countertop and the toe kick as well. And like I said, sometimes it worked and sometimes it got hairy, just like curtain walls. Curtain walls, when you're working with them, the joints get sometimes a little hairy, and the same thing will carry through to the casework as well.
What about sinks? Can you add a sink to the top?
I would assume, as long as your sink component family has a
void.
A void, thank you.
Yep.
Yeah, okay. That works. And it's you can host plumbing fixtures, deck mounted fixtures to the stuff too. So it's space-based and you're using the proper plumbing families.
Okay. All right, one last question as we come to the top of the hour, just to kind of close everything up. Do you have any plans to evolve this into a plugin for deeper customization? You guys thought about that?
Who is that directed to?
I have not. I have not. I mean, like, that would be great. I believe this is in its early stages, but I think that having a plugin, I think that maybe it's more an ATG's wheelhouse for that. But yeah, we've seen some great plugins for other types of things, and it's really pretty cool to have something like that.
Yeah, I think this is a obviously this is the phase one of the development of this for, specific for what you guys use it for. I think it's a very valuable tool for the, like you said, the flexibility and to be able to have this early on. And I thought it was a very unique approach to a solution to an issue that you guys were having internally. I think definitely want to explore it more as well. So any final closing thoughts, Matt and Nick, before we go ahead and wrap it up for the day?
I'd like to thank Nick and Eigelberger team. I mean, I had never thought of this, and like Nick mentioned, it's probably happened before, but it really is a great solution. Like the flexibility, the speed, how it rolls seamlessly into DD and CD. I mean, it's wonderful. So, thank you to the Eigelberger team for collaborating with us and giving us this opportunity.
Yeah. Oh, thanks, and thank you guys for developing this and really grasping the intent that we have here and seeing and foreseeing some of the potential issues that we might encounter and addressing those. I think it's been really great working with you, and I'm definitely looking forward to continuing the evolution of this, but also other tools. I think there's a couple questions just really quickly about tagging stuff. You can tag materials. Typically, we just tag materials and hardware and other objects, but that's completely possible with this, provided the materials are chosen and the tags are available. So.
Plus, you can make a wall tag that appears to look like your casework tag. So it's simply going for that category. If you're using TG or tag category, it's just a wall tag.
Well, thanks to both of you, and thank you everyone who joined us today. If you have any follow-up questions, you can reach out to Matt, myself, or Nick, and we'll definitely get back to you. And I'm excited to see what we're going to present next. Thank you all for your time today.
Yeah, thank you.
Thanks, everyone.
Thanks, guys.